Alright guys, so we're going to talk today in our lesson mainly about how do we find the length of a curve, a parametric curve and then just a regular function curve. But before that, I want to start with something that is seemingly unrelated, but obviously is of course clearly related. Speed. So let's say we have a plane, and not the drug, right? So let's say we have a plane, and this plane flies 30 meters per second due east, and 40 meters per second due north. What is the speed of the plane? And in a sense, what they're asking you to find is basically the magnitude of this velocity vector. So when you think about, like, from a graphical sense, what's going on is you're saying, okay, we're starting here, we're going 30 meters per second to the east, we're going 40 meters per second north. So if we want to find the overall speed, like the overall direction that we're going is in this direction right here. Right, that's our overall direction. So that the way we find that side length, of course, is we use the Pythagorean theorem. And the speed, in this case, we take the square root of 30 squared plus 40 squared, and you recognize just a 3, 4, 5 triangle is 50. But in general, the way you're finding the overall speed of an object is not with an integral. You're just taking the square root of the dx dt squared plus the dy dt squared. Okay, so that's the general process of how you're going to find a speed. And this is like our first of the 3 key equations we're going to get through today. So the way we find speed is, again, just like the magnitude of the velocity vector. Okay, great. So let's go on to this. So let's say we have this question here. You have, not an example, let's say you have a parametric length of the curve. So let's say you have some object in the y-x plane that is moving around a parametric curve and something like that. And you want to ask yourself, like, okay, if I start at one time and I end at another time, you might ask, what is the length of the curve from one point to another? Okay, so basically what this is doing is saying, okay, if we start at one point, if we were to like lay a layer of dental floss along the curve from one point to the other, and then we were to straighten that floss out, how long would it be? That's what we mean. Like, what is the distance along there? So thinking about this, the length of the curve is actually equal to, well, we would think about that as the total distance that is traveled by someone walking along the curve. It's the distance traveled by walking along the curve. Well, let's think back to last semester. How did we find a distance traveled? Well, distance traveled was just the integral from a to b of the speed. Right, and really what it was is it was the integral from a to b of absolute value of velocity, but that's just how we define speed. So how do we take the integral from a to b of speed? Well, we just do the integral a to b of using that equation we just came up with, the dx dt squared plus the dy dt squared. So we're saying that the length of that pink highlighted curve is the same as the distance that someone travels by starting at one point on the curve and ending at another point on the curve. That just tells you how long the curve is, right? If you walk 3 miles on a path, the path is 3 miles long. So this is how we find the length of the curve. And this is actually our second key equation from the day. Okay, and this is a useful formula that we're going to use a ton. So let's look at a couple examples. And anytime someone asks for the length of the curve or a total distance traveled in parametric, and I think that bears repeating, this formula only works if you have a parametric equation. But this is how you find the length of a curve, the total distance traveled in parametric. So let's look at a couple examples here. So let's say we have a cat. I don't really like cats, but whatever. A cat moves with the position function. X of t is equal to 4t squared minus 3t plus 1, and y of t is equal to 3 sine of t. Okay, and then I'm going to ask you to find the distance traveled by the cat from t equals 1 to t equals 4. Okay, So we're going to use this equation because this is how we find the length of the curve or distance traveled. And in terms of solving this, the t equals 1, t equals 4, that's your a and your b. So, okay, so I'm just going to plug in and use this formula. It is really just a useful formula. So let's find the derivatives first because we need those. The dx dt is just 8t minus 3. The dy dt would just be the derivative of my y equation. So that would just be 3 cosine of t. All right, so what that means is if we want to find the distance traveled, the distance that we are going to travel here, what that is that just going to be the integral from 1 to 4 of square root of, okay, so the dx dt squared plus the dy dt squared. So that's 8t minus 3 squared plus 3 cosine of t squared. Okay, so now we just have to do this integral. Does anyone see an easy way to do this integral? Oh, I do. It's a freaking calculator. These integrals are disgusting. So almost all these, you're just going to plug them in your calculator. When I plug this in my calculator, I get a value of 51.359. Just use your calculator. Hopefully I got that right. We'll find out in class. Okay, so that's how you find the distance traveled. Let me give you one more to try. So suppose I give you x of t is equal to 3 cosine t, and then y of t is equal to 3 sine of t, and I'm going to ask you to find the length of this curve. And I'm always going to give you bounds on the length of this curve from t equals 0 to t equals 2 pi. Okay, so give that a sec. I'll give you a minute to try it on your own. Just pause the video. Okay, great. So the way we find the length of the curve, of course, the a and the b are 0 to 2 pi, so that's integral 0 to 2 pi of square root. And then we just have the dx dt squared plus the dy dt squared. Okay, so you work this out. Your dx dt squared is like, all right, the derivative of that is negative 3 sine of t squared, and the derivative of that is 3 cosine of t squared. Okay, now this is something, of course, you could plug in, but it's too beautiful not to. So this just turns out to be square root of 9 sine squared t plus 9 cosine squared t dt. So that just becomes square root of 9 times sine squared t plus cosine squared t. All the cool kids know sine squared plus cosine squared is just 1. So this just becomes integral 0 to 2 pi of square root of 9 dt. So that's just 3t going from 0 to 2 pi, which just ends up being 6 pi minus 0, which is just 6 pi. Cool. Now, this answer should, of course, make perfect sense. If you plug in your calculator, it's like a little less than 20. Because what this does is this makes a circle, right? We just found what is the length of a circle as we go from 0 all the way around to 2 pi. So if you ever forget the circumference of a circle, but remember this length of the curve formula, you can use this. So, cool. Okay, so that's how we find a parametric length of the curve or a total distance traveled. We're just going to use that formula. So let's go back. We're going to leave parametric briefly. And we'll be back to it tomorrow, don't worry. And we're going to find the length of a curve with one variable. Okay, but I want to start with the parametric one. So in parametric, we have x and y in terms of t. So we have that length of the curve is equal to integral a to b of square root dy dt, let's do it in the right order, dx dt squared plus dy dt squared. So now I'm going to do a little bit of black magic, and we're going to see what happens. Well, if you just have a length of a curve in one variable, that's just like a regular function where y is some function of x. So what that means is now x is the variable, not t. So let's just go ahead and replace all the t's with x's. That's an x, that's an x, that's an x. So if I just have a regular function, like y equals 3x plus 4, the length of that curve is equal to integral a to b of square root. Well, what's dx over dx? That's just 1. So that's 1 plus, and then dy over dx is just y prime of x, or just y prime or f prime or whatever, squared. Okay, and this is our third key formula. This is just your formula for arc length. And this just tells you what is the length of a curve that you have a regular function, not a parametric function, but just a regular function. So this is, again, not for parametric. And for your homework, you'll see some that are parametric and some that are just a regular function like we've been doing all year. Okay, so for example, suppose I tell you that y equals sine of 2x plus 1, and I ask you to find the length from x equals 0 to x equals 1. Or sorry, x equals pi. So what you're looking at is like if you were to graph this function, so you start up 1 and then you just kind of graph the function, it looks roughly like that. You're basically just saying, okay, if we start at 0 and we go to pi right here, what is the length of that curve right there? So again, how long do you have to travel along that curve? And really, anytime someone asks you to find the length of a curve, you're really just going to use this formula for arc length. So the formula says, okay, and again, the 0 to pi or a and b, you're just going integral 0 to pi of square root 1 plus f prime squared. Okay, so you're just going to find f prime and then plug in. Okay, so if your function is sine of 2x plus 1, then your derivative of that is 2 cosine of 2x. So that means that your length of the curve is equal to integral 0 to pi of square root 1 plus parentheses 2 cosine 2x squared. And that's an interval. And again, I'm not going to do this, but you'll just plug this in your calculator. Okay, so one other type of question where you'll see this formula, a lot of times they'll just say, what is the length of the curve? And you'll do a problem related to that. But you might also use this to find a perimeter. So one shape that they had, and this is very similar to an AP problem that was a couple years ago, is you had a curve that looked like this, and you were going from 0 up to 5. And you had this function, f of x, was equal to e to the negative 2x. And then they shaded this region right here and just said, like, find the perimeter. And perimeter, of course, just means the distance around. Well, in this case, what you do to find the perimeter is you just do the bottom plus the top plus the left plus the right, right? You just find the four sides and you add those together. Okay, now the bottom, of course, is incredibly easy. That's just 5, right? You're saying what's the distance from 0 to 5. What about the top? Well, the way we're going to find the top, that like curve along the top, so that blue length is the length of the curve. So you're just finding the blue length of the curve for this function right here. So if your function was e to the negative 2x, then your derivative of that would be negative 2e to the negative 2x. So when you plug in your formula here, you're saying, okay, I'm going from 0 to 5 of square root 1 plus, and then that's negative 2e to the negative 2x squared. Okay. Now, for the left side here is just the height at x equals 0. So that's just like, basically, that it's the height right there. That height is just whatever f of 0 is, which turns out to just be e to the 0, which is 1. So let's do 1. And then the right side is just the height on the right side, so it's just the height at that point, f of 5, which is e to the negative 10. Okay, so this is how you would find the perimeter of the shape. The only difference here from what we know before is just doing the top. The way we find the top, the way we find that length of the curve is using that formula we just did. And again, this is the formula for a regular function versus a parametric. Okay, hope this helped. Thanks for watching. I'll see you guys soon.